Yeah. See, as we have discussed our time of flight t equal to 2u sin theta by g, and range is equal to u square sin 2 theta by g, and h is equal to u square sin square theta by 2g. Now come to this. Now my question is there any possibility to have same range for two different angles of projections? Is it possible? Means my question is like this. I would like to throw like this with certain velocity u. With same velocity, I would like to throw the same ball, but my angle of projection is different. But my aim is to get the same range. Is it possible? Means if I throw a ball like this, it has to fall at the same location. So is it possible? That's my question. Tell me whether it's possible or not. That's my question. Here my friend is there. I would like to hit him with some gun which can give a certain velocity. So I can fire like this and I can fire like this. In both the cases, it should reach my friend. It should hit my friend. Is it possible? That's my question. Okay. Before that, let us see the formula for range u square sin 2 theta by g. Means this r is directly proportional to what? Sin 2 theta. If theta is equal to some alpha and theta is equal to 90 minus alpha, what is this r? Let us see. R is proportional to sin. Instead of theta, I am going to write alpha. Sin 2 alpha. This is case 1. In second case, I would like to write r is proportional to sin 2 into 90 minus alpha. So, proportional to sin 2 into 90, 180 minus 2 alpha. What is sin 180 minus 2 alpha? It is nothing but sin 2 alpha. Means in the case 1 and in case 2, we got same result. R is proportional to sin 2 alpha, R is proportional to sin 2 alpha. Means if the angle of projection is even alpha or 90 minus alpha, we will get the same answer. So what are these two called as? Alpha comma 90 minus alpha. They are called as complementary angles. So when the angles are complementary, we will get the same range. So it's possible to have the same range even the angles of projections are different. The angles of projections must be complementary. Means if theta is equal to, if theta 1 is equal to 10 degrees, what is theta 2? Must be 80 degrees. In the two cases we get the same range. If theta 1 is equal to 30 degrees, what is the theta 2? Also must be 60 degrees. Then we get the same range. Because 30 plus 60 equal to 90. Would you like to check it? Okay. 60. If theta equal to 30, let us see R1 is equal to u square sin 2 into 30 by g. That is equal to u square sin 2 into 30 means 60. Sin 60 means how much? Root 3 by 2. Root 3 by 2g. These are R1. So what about R2? When theta equal to 60. U square sin 2 into 60 by g. Okay. U square sin 2 into 60 means how much? Sin 120. Sin 120 can be written as sin 90 plus 30 means cos 30. Cos 30 means root 3 by 2. By 2g. So from this it is very clear that R1 equal to R2. Both the cases we got same range, but the angles of projections are different. Is it clear? So it is clear that we can achieve same range even with the angles of projections are different. The angles of projections must be complementary. Is it clear? Fine. Now let us see what is its velocity at any instant of time. Say for example, you have thrown an object like this, and after some time it is here, but I want to find its velocity at that time. As this is thrown with a velocity u with an angle theta. If such is the case, ux is equal to u cos theta and uy equal to how much? Similarly, uy equal to u sin theta, vy equal to how much? So, as you know that along x-axis there is no acceleration, that's why velocity remains constant. That's why uy is equal to u cos theta only. But along y direction there is a gravity. Due to that velocity changes. So final velocity, if I write here, v is equal to u plus at. Along y direction I need to write. So vy is equal to u means u sin theta minus g times t. You know why I wrote g here. G is acting in the downward direction. Uy initially upward direction, velocity in the upward direction, gravity in the downward direction. If I take this as up, this is down. So these are uy. Now my velocity, if I write it in vector form, this is ux into I cap plus uy into j cap. So v bar is equal to ux means u cos theta into I cap plus u sin theta minus gt into j cap. Okay, if you are aware of the vectors, you can easily understand this. Otherwise, keep it in mind, revise my vectors concept, you can understand this. Okay, now what is the magnitude of this velocity? Modulus v bar is equal to tau x component square plus y component square. That's why it is u cos theta whole square plus u sin theta minus gt whole square. So if you can substitute the value of time here, for example, after 1 second, after 2 seconds, after 5 seconds, after 20 seconds, after 30 seconds, whatever, you can find the velocity at that time. Is it clear? Same as this, but here we have to find displacement. Yes, x equal to how much? Yes, y equal to how much? Our displacement vector is given by sx I cap plus sy j cap, and modulus of s bar is equal to root over sx square plus sy square. Is it clear? Now what is our sx? Displacement along x-axis. ut plus half at square. So sx is equal to ut. U means ux, ax. U cos theta into t plus half. Acceleration along x-axis is 0, so no need to write. These are sx. What about sy? Displacement along y-axis. Uy into t plus half uy into t square. Uy is u sin theta into t minus half g into t square. This is our sy. So put this x-axis here and sy here. You will get the vector form of our displacement, and if you want to find the magnitude, put the sx here and sy here. You will get the magnitude of displacement at an instant of time. You can substitute the time value here. Okay, this is our displacement at an instant of time. So these are our theoretical concept about our projection. In the next lecture, I am going to discuss many problems on this concept. Okay, see you all.